The next topic in chapter 2 is formal charge, and it is a topic that is closely related to bond polarity and dipole moment, which we talked about in our previous video. Knowing how to assign formal charges to atoms is extremely important for your studies in Chem 235. So we will look at how to calculate formal charge. See? As the name suggests, formal charge is just a formalism. It is not an actual charge. So molecules may look neutral, but you may be able to find out the formal charge of individual atoms in the neutral molecule also. Okay, usually it is the atom generally has a formal charge when there is an abnormal bond in there. Okay, so when I say abnormal, it means that it's either forming bonds less than what it actually would like to form, or forms bonds more than what it actually likes to form. For example, this is a molecule of dimethyl sulfoxide, and as if you recall from our first chapter, sulfur belongs to the same period as oxygen, so it generally likes to form 2 bonds. Okay, but in this case, in this molecule, look, sulfur is forming 3 bonds, so it's kind of an abnormal way of bonding for sulfur. Oxygen always likes to form 2 bonds in its happy state, right? However, in this case, it is forming a single bond, so which is again not the usual form in which oxygen likes to form a bond. So that is when we are able to calculate the formal charge on these individual atoms. Now carbon here, if you look, it likes to form 4 bonds, and it is forming 4 bonds, so it is having a formal charge equal to 0, which is not represented here, but it is equal to 0. Okay? So let's see how we can calculate the formal charge in an atom. It's important for us to know the formal charges, because then we can talk about what part of the molecule reactions will occur. So if it is a positively charged center, then we know that any electron-rich species will come and try to attack here. Now, if you have a positively charged species, then it will come and attack at this oxygen atom because it has got a formal charge of minus. So when we do organic reactions, it's very important for us to be able to calculate the formal charges at different parts of the molecule or different atoms of the molecule. And how do we do that? We can use this formula, which is the number of valence electrons in a free atom minus the number of bonding electrons divided by 2 minus the number of non-bonding electrons. Okay? So for example, the same example of dimethyl sulfoxide, you can see that for sulfur, the number of valence electrons is 6. So the group number represents the valence electrons. So for sulfur, the group number is 6. So it has got 6 valence electrons minus half the number of bonding electrons. Now, how many bonding electrons does it have? You will have to count both of these. So 1, 2, right? Each bond represents 2. So 1, 2, 3, 4, 5, 6. So there are 6 bonding electrons. You have to take 1/2 of that, because only half of that belongs to sulfur, right? So half the number of bonding electrons minus the number of non-bonding. Now in this case, how many non-bonding electrons do you have? You have 2 of them, right? So you subtract it from 2. So 6 minus 6 over 2 minus 2 gives you a formal charge of +1. Same thing for oxygen. Valence electron is 6. How many bonding? Again, make sure you count both of them here. So 6 minus 2 over 2 minus how many lone pairs of electrons? 1, 2, 3, 4, 5, 6, right? So minus 6 gives you a -1 as your formal charge. Okay, let's practice some more. Okay, so before that, look at this table. This is a summary of the common formal charges. So for example, carbon, if it is forming all the 4 bonds, then it will have a formal charge equal to 0. Okay. However, if it is forming only 3 bonds, it will have a formal charge of +1. If it is forming 3 bonds with a pair of electrons left over, then it will have a -1 charge. Nitrogen, generally it likes to form 3 bonds when its formal charge will be equal to 0. when it is forming 4 bonds, then it will have a formal charge of +1. If it is forming only 2 bonds, then it will have a formal charge of -1, etc., and so on. Okay, so you don't have to memorize this, but it is kind of good to know so that you don't have to go back and use the formula every time to calculate the formal charge. Okay, so for example, if I draw out this molecule, right, NH3, NH3, okay, and then ask you what is the formal charge of nitrogen. So you can actually use the formula, which would be what? Number of valence electron, which is so we are calculating that for nitrogen. Okay, 5 is the valence electron minus 1/2 of the number of bonding. How many bonding electrons? 1, 2, 3, 4, 5, 6. Okay, 6 minus any lone pair, 2. Okay, so this will be equal to 5 minus 5, which is equal to 0. So then you don't have to do this entire calculation. If you recall that nitrogen is always in a happy state when it is forming 3 bonds. Okay, so happy states of atoms, then the formal charge is equal to 0. Same thing with water, right? So you don't have to use the formula to calculate the formal charge of oxygen, because you know that this is the happy state of oxygen. It is forming 2 bonds, so the formal charge here would be equal to 0. Okay, so same thing for nitrogen, it is equal to 0. But if I draw a molecule like H3O plus, like this, okay, and tell you that this has got a positive, it's a positive, the hydronium ion, you must remember it from Chem 152. This is the hydronium ion. Okay, now if you look at, can you tell me what will be the formal charge of oxygen? It is not the happy state because it's forming 3 bonds, so you can use the formula here. Oxygen will be equal to 6. Okay, let me write here. 6 minus 1/2. How many bonding? 1, 2, 3, 4, 5, 6. 6 minus how many lone pairs? 2. Okay, so this will be equal to 6 minus 5, which is equal to +1. So here the formal charge on oxygen is equal to +1. Okay, so that's how you have to calculate it. In the next slide, I have a learning check, which you can use to see if you have understood the concept of formal charge. 3 molecules are given: diazomethane, acetonitrile oxide, and methyl isocyanide. And you have to calculate the formal charge of each atom in each of these molecules. The first one is worked out here. We have CH2 double bond N double bond N. Okay, and you have to calculate that for carbon and the 2 nitrogens separately. So for carbon, remember the formula is 4 valence electrons minus how many bonding? We have 1, 2, 3, 4. Then there are 2 for the hydrogens too, right? So that brings it to a total of 8 divided by 2. Any lone pairs? None. So -0. So the formal charge on carbon comes out to be 0. For nitrogen, this nitrogen, the central nitrogen, you see that valence electron is 5 minus how many bonding? Each bond represents 2, so 2, 4, 6, 8. So 8 divided by 2 minus any lone pairs? There are none. So -0, and that comes out to be +1. Okay, so the formal charge on this nitrogen atom is +1. What about this nitrogen atom? 5 valence electrons minus 4, because there are only 2 bonds here. So 1, 2, 3, 4. Okay, 2 bonds here. So 4 bonding electrons divided by 2 minus how many lone pairs? 1, 2, 3, 4. So this nitrogen here gets a formal charge of -1. So we have +1, -1, and this one will be 0. Okay, Do you want to do another one? Okay, let's try this one. Okay, methyl isocyanide. So we are going to do the next one, which is methyl isocyanide. Let me draw this out first, okay, with the individual bonds. So we are doing C, which is this one. Okay. This is the one we are working on. So we have carbon, hydrogen, hydrogen, and a hydrogen, then a nitrogen, triple bonded to another carbon, and with a lone pair. Okay. So let's do for the carbon, which we can represent in blue color. Okay. So for my blue carbon, I have valence electrons equal to 4 minus 1/2. How many bonding? 1, 2, 3, 4, 5, 6, 7, 8. 8 minus how many lone pairs? None, right? So this comes out to be 0. So the formal charge on this carbon atom is 0. Then for nitrogen, how will you calculate it? Number of valence electrons, you can look up at the periodic table, 5 minus 1/2. How many bonding? 1, 2, 3, 4, 5, 6, 7, 8. 8. Do you have any lone pairs? No. So 0. Okay. Should have pushed a different color here. Nitrogen. Nitrogen. Okay. We have 5 minus 1/2 times 8 minus 0 will give it the answer to be plus 1. So the nitrogen here is plus 1. And finally, let's calculate for the carbon. Let's put that in green color. So for my green carbon, number of valence electron remains the same, 4 minus 1/2. Okay, how many bonding? 2, 4, 6. 6 minus how many lone pairs? 2, right? So we have 4 minus 3 minus 2, which is equal to minus 1, negative 1. So this one has a negative 1. So overall, this molecule is neutral. Okay, so overall this molecule is neutral. Why? Because there is a positive charge and there is a negative charge to balance it. So overall the molecule is neutral in nature. However, you can actually look at each of the atoms and figure out the formal charges. So you must have understood that formal charge is not a actual charge. It is just a formalism. Okay, but it helps us to target which atoms can at which atoms the reactions can happen depending upon whether it has a positive charge or a negative charge. Okay, so I would like you to take this example and work it out by yourself. This is from your textbook, so you can easily look up at the answers for it and make sure you practice some more examples to understand the concept of formal charge. Okay, so see you guys in the next video. We'll talk about resonance in the next video.